Kia ora koutou. In this video we're going to introduce the mechanics concept of work. So work is another word that we use often in everyday context, but in physics it has a different meaning. So in physics it means the transfer of energy by a force. So the transfer of energy by a force. So if we take a box, lo and behold, what are a couple of things that we could do to this box to transfer energy to it by using a force? So one thing we could do is if we applied a force on a horizontal axis, then that would accelerate the box, and so we would be increasing the kinetic energy of the box. So we could apply a force to increase the kinetic energy of the box. That would be one way. Another way that we could transfer energy to this box is the other form of energy that we've learnt how to calculate during this topic, which is gravitational potential energy. So if we were to apply a force in the vertical upwards direction, then we would be able to increase the gravitational potential energy of the box. So for level 1 mechanics, the work done on an object will either assess the increase of the kinetic energy of the object or the potential energy of the object. Never explicitly, but for me, this just having an idea of the two different forms of energy that work can be done on an object to increase just helps me to understand things a little bit more. So the formula that we have for work is work, which is a capital W, equals force times distance. So if we, well, I'll just write that out for you. So work, the capital W is work. Work is measured in joules. So work is the transfer of energy. So if we're transferring something like we've got joules as the currency that's being transferred, so it makes sense that the work is measured in joules as well as energy. So work is effectively the transfer of energy, so measured in joules. Force and distance we've come across before, so capital F for force is measured in newtons, and the lowercase d is distance, measured in meters, the distance. So if we were to apply a force to this object vertically, let's say it was, why not 200 newtons, or we'll just say 20 newtons, and it went up 2 meters, let's say this distance was 2 meters, then we would just plug these values into our formula, 20 newtons times 2 meters, and the work done would be 20 times 2, so 40 joules. Likewise, if we were to horizontally apply 40 newtons of force, 40 newtons, and it was over a distance of 3 meters, then that would be 40 times 3, so we would end up with 120 joules of work. What often happens with the gravitational potential energy is we are just given the mass of an object, so we might be given the mass of this box, which could be 2 kilograms. If the mass of the box is 2 kilograms, the force required to lift it will be the weight of this box. So to work out the force, if we're given the mass of an object, we need to use the weight equals the force times acceleration. Oh, sorry, weight equals the mass times acceleration, acceleration being gravity. So that would be 2 times 10, 20 newtons. So if we have the mass of an object and we know how the distance that has been lifted, then we can just go the mass times 10 times the distance, and that'll give us the work done on the object. We'll go straight into a couple of past exam questions. So the first one, you'll see what I mean when I say they don't explicitly say that gravitational potential energy has been increased in the object, but this first example we'll go over is effectively talking about gravitational potential energy. So Willow had to choose between 2 ramps to ride her bike to the top of an incline. It takes less time to use ramp B. So we're going to get into this aspect of time. This is going to increase something different, but is the work needed to get to the top of ramp A more, less, or the same as the work needed to get to the top of ramp B? Well, in both scenarios, we've got a 3-meter ramp and a 2-meter ramp. They both have the same vertical incline, so they both go up 0.5 meters. So because effectively the gravitational potential energy of the bike will be increased by the same amount, in both cases it doesn't matter which ramp you use, the same amount of work is required to lift the bike. So we'll say both the same amount of work is required because um, the vertical distances are the same. Brilliant. So that's all we need to write for that one. We'll go on to the next question that follows on from that. So explain how the two ramps differ in terms of the force and power needed to ride up them. So power, we'll come across this in the next video, but we won't talk about it now. That's where the time will come into play. But explain how the two ramps differ in terms of force and power, or force. So we know that work equals the force times distance. So work equals the force times the distance. For both of, no matter which ramp you go up, the work is going to be the same. What's different is that the distance in each ramp changes. So for ramp B, the distance is 2, and for ramp A, the distance is 3. So if we've got the distance being, let's say we'll do this for ramp A, if the distance is 3, and where there's an unknown force that's going to be applied to that object to equal the same amount of work, how much would there be a lesser force or a greater force required compared to B? So what we work out is that for ramp A, a less force is required over the greater distance to equal the same amount of work. So less force is required on ramp A than ramp B. We'll move across to a past exam question that talks more about increasing the kinetic energy of an object. So Sam's horse accelerates for the first 10 seconds. I've taken the second and third parts of different exam questions, so we don't know quite the context, but we can still work it out. So Sam's horse accelerates for the first 10 seconds of a race and covers a distance of 40 meters. Sam and his horse have a total mass of 308 kilograms. Use the acceleration to calculate the work that Sam and his horse have done in the first 40 meters. So we can work out from a graph that they give us, which we're not going to go through in this video. This is taken from, I think, the 2017 exam. So that's the acceleration is meters per second per second. We need to calculate the work. So the work, we use the same formula. Work equals force times distance. Well, we need to, what is the force? We're not given the force here, are we? So force, we can look at our formula sheet that we're given at the start of the exam. Force equals m mass times acceleration. We know the acceleration and we know the mass of the object, or of Sam and Sam's horse. So we just need to enter these values in here. So we've got 308 times 0.8. 0.8 equals 246.4. 246.4. And that's newtons, and then the distance is 40 meters. So we just go 246.4 newtons, 246.4 times the distance, which is 40, and we get 9,856. 9,856 joules. Thanks very much for watching. I hope this helps out with work. Like and subscribe for more Science 1.1 videos. Thanks a lot. See you next time.